Hello, and welcome to Managing the Insider Threat, what every organization should know. Depending on your location, we wish you a good morning, a good afternoon, or good evening. My name is Shane McGraw, your moderator for the day, and I'd like to thank you all for attending. The CERT Insider Threat Center conducts empirical research and analysis to develop and transition socio-technical solutions to combat insider threats. They've been doing this research since 2001 and in partnership with the Department of Defense, the Department of Homeland Security, the U.S. Secret Service, numerous other federal agencies, the intelligence community, private industry, academia, and the vendor community. We have a great lineup of cybersecurity experts assembled to speak today, and you will see the agenda on your screen now. We want to make today as interactive as possible. We want it to be a discussion, so we have left 15 minutes for question and answer at the end of each 30-minute presentation. Now I'd like to introduce our first speakers, Randy Trzeciak and David Mundie, and they will be speaking on an overview of the threat posed by insiders to critical assets. Randy is the technical manager of CERT's Enterprise Threat and Vulnerability Management Team, as well as the CERT Insider Threat Center. The team's mission is to assist in improving their security posture and incident response capability in conducting information security assessments, providing information, solutions, and training for preventing, detecting, and responding to illicit activity. Our next speaker, the second speaker I should say, is David Mundie. And David is a member of the CCERT development team within CERT. He has been at CERT since 2000 and has worked in a variety of areas, including insider threat, malware analysis, incident management capability metrics, and from 2006 to 2009, he was a member of the Q-CERT project, which established a national information security team for the country of Qatar. David, Randy, welcome. I'll pass it over to Randy to get us started.
So again, my name is Randy Trzeciak. I'm the technical manager of the Enterprise Threat and Vulnerability Management Team, and it's certainly a pleasure to be here with you sharing some of our research, the work we've done over the past 13 plus years, and we certainly welcome you throughout the day to attend many of the presentations or the presentations that you find valuable to your particular organization. So in terms of an overview this morning, David and I will be going through an overview of the insider threat and going through some of the needs and requirements for an insider threat ontology. The next session then will progress to best practices for the mitigation of insider threats, as well as the controls more from a technical side, technical controls that can be put in place to address insider threats. And then we'll move into building an insider threat program. Then we'll get into other topics such as synthetic data, how you can use synthetic data to test some of the control and the work that you're putting in place to mitigate the insider threats. And then we'll get into a topic, emerging trends, specifically related to insider threats. Insider fraud will be discussed in the afternoon, specifically looking at the insider fraud incidents and what you can do from an organization to identify fraud and what you can do to prevent or detect that. And then finally, we'll get into a panel discussion looking at the challenge problems that organizations will face as they try to address insider threats within their organization. So again, welcome, and we certainly wish you the best throughout today, and if we can have and provide any support following these webinar sessions, feel free to reach out back to us. So in terms of the background of the Insider Threat Center, as was mentioned, we've been doing insider threat research since about 2001. We began with work with the United States Secret Service. When that particular study started, we were provided with 150 incidents that the Secret Service was investigating, and what we were trying to do was to analyze those incidents to look for common patterns. Since 2001, we've continued to collect cases to the point where we're at 800 plus cases now, and really what we want to do is to analyze those cases to determine, are there patterns of activity? With the original studies back in 2001, we identified the need to identify both technical patterns as well as non-technical patterns. And some of those patterns then will allow us to develop and transition the socio-technical solutions to combat the insider threat problem. So the team that we have here in CERT is primarily comprised of technologists, bringing the technical aspects. Throughout the years, we've been privileged to work with behavioral psychologists who have really allowed us to focus on the behavioral aspect of the insider threat problem. And what we believe is that we should in addition to applying technical solutions, look at the behavioral aspects of the insider threats to see if there are ways we combine them both. So the Insider Threat Center is comprised of 3 primary teams. The Insider Threat Center has a research component, a technical solutions component, and an organization solution component. And then from that, we do have the ability then to transition across the teams to really provide solutions to the organization across the entire spectrum. The research team contributes to the technical solutions team. The technical solution team then provides input to the organization solution team. So again, if we can provide any assistance in the future, feel free to reach back out to us. And again, our goal is to look at the socio-technical solutions to combat the insider threats. So in terms of the goal for an insider threat program, what we believe is that a technical solution alone may not be the most effective solution. If we look at the timeline from when someone comes into an organization until and when they progress through their time within an organization, we believe that there may be some technical indicators that could be observed. Again, we try to differentiate between indicators and observables. Again, to date, we have not found what is the indicator of someone progressing down the path to be an insider threat or someone who's going to harm an organization's critical assets. What we want to present to you in this first session is what we believe are observables, things that you as an organization could observe, which then you should factor into your enterprise-wide threat assessment across the entire organization. So if you have the ability to collect these technical indicators, that's one piece of identifying individuals who may be more at risk. But also we want to ask you as an organization to identify some of the non-traditional technical data sources. As you see it in the top of this diagram here, do you have the ability across your organization to look for human resources observables, the legal aspects, the physical aspects of your organization? Again, our hypothesis is that if you look across the organization, you combine the technical observables with some information across the organization, you might have a better chance of identifying people who may be more at risk at harming your critical assets. And we do want to say right up front that the insider threat is certainly a low occurrence event. Not everyone in your organization is a threat to everything. And we do want to say that the frequency is relatively low. Not everyone is going to go on to be an insider threat to your organization. So what we want to do is be able to balance that across the perspective of what are you trying to protect, and then who are you trying to protect it from. So again, the goal is, can you combine both the technical observables with the non-technical to identify people who may be more at risk? So our unique approach to the problem is that we try to develop these research models. The research models are empirically based, where we want to look at the actual case data. As I said, we have about 800 cases in our database today. We want to develop these research models which describe the very complex problems of the insider threat. Okay, so we build these research models. But what we want to try to do, in addition to be an academic research organization, we want to be able to transition that to an applied research or an operational perspective. So what we do is we take the research models that we've developed, which are based on actual incidents, and we try to develop and propose candidate controls and indicators. So as we move from the research model, the top left of the chart here, to the right side, what we want to be able to do is to take a component of the insider threat problem and then transform that into what you see at the bottom here is a technical control. This particular technical control will be discussed in more detail in a future session when we talk about the best practices and controls. But really what we want to be able to do is to develop ways that the operational community can prevent or detect what could be suspicious activity on your networks. This particular control is related to the theft of intellectual property. What we found based upon the empirical data is that about 75% of individuals who take intellectual property do it within 30 days of announcing they're going to leave the organization. So what we term this is the 30-day window of opportunity. So do you as an organization have the ability to watch what people are doing who announce they're going to leave the organization? If so, you might want to configure your controls to specifically look for things that might be considered suspicious activity, such as someone using email to send something off the network, which may include an attachment to someone off of your particular domain. So someone that could be a competitor, that could be some other organization, or that could be some foreign organization outside of your particular control. So here, what we want to try to do is to give you some specific advice in terms of how you can prevent or detect suspicious activity. And this is specific to theft of intellectual property. So again, we have many more controls, and we'll talk about that in a subsequent session. So when we talk about the insider threat, we want to be clear that there is not one type of insider threat. Okay? Contrary to what might be displayed in terms of media reports or some other types of reports that come out, there isn't one specific insider threat, and not everyone is a threat. What we want to convey is that you as an organization need to consider that in the context of what you're trying to protect. What are your critical assets? And that should certainly be the first point in you putting a strategy in to protect those critical assets. What we want to propose is there are 4 categories of critical assets. The first being your people, second being the information, the third being technology, and the fourth being facilities. And that should be the start of any enterprise-wide risk assessment. What are you trying to protect? What is critical? Who has access to it? Where does it exist? And who should have access to it? That should be the foundation of all of your risk mitigation strategies. When we start looking at the insider threat, you want to consider some of the potential motives of the insider. What I want to propose to you today is 3 primary motives, and it also combines the impact to the organization. And the impacts to those assets would be the confidentiality, the availability, and integrity. Okay, and again, from our perspective, we don't believe that there's one solution for addressing the insider threat. It should be combined in a defense in-depth strategy. Many ways to prevent, many ways to detect. With that, you might have the ability to identify someone who may be more at risk, and you might be able to identify suspicious, but maybe not always malicious activity. And as I said at the beginning, we believe that technology alone may not be the most effective way to prevent or detect an incident perpetrated by a trusted insider, because they're already a couple levels into and bypass some of the controls you may have in place. Again, technology from a standpoint is very good at detecting activity, but we haven't found technology, at least to date, that's able to identify the motives of the insider, the malicious intent. And that's where we want to combine some of the behavioral aspects of the insider threat problem. So what I want to ask you to consider is, can you separate the target from the impact from the actor itself? And what we mean by that is looking at the target. Going back to the foundation, what are your critical assets? Focusing on the people, the technology, the information, and the facilities, what they are. What are your critical assets? And then when we start combining, what is the impact of those assets, including the confidentiality, availability, and integrity. And then finally, we get into who has authorized access to those assets and what could they potentially do. And when we look at the actors or the people who have authorized access, we've broken those down into employees. The cases we've collected so far are current as well as former employees. A number of the cases we have are people who have already left the organization and still have the access to harm the critical assets. So certainly consider your former employees. Expand the definition of what an insider is to include your contractors, your subcontractors, your suppliers, and trusted business partners. Really, anyone that you give authorized access to those critical assets should be factored into that enterprise-wide risk assessment. So with that being said, not everybody is a threat to everything. I want to dispel the myth that you as an organization need to watch everybody in terms of the critical asset protection strategies. Again, from a standpoint of identifying the target and the actors with authorized access, that's where we want to focus our protection strategies. When we define insiders, we break it into 2 primary categories. This will get into David's ontology discussion. The cases we've collected so far are malicious insiders, people who intentionally harm the critical assets. These are people who intentionally exceed or misuse their access, and it affects the integrity, confidentiality, and availability. And it does include the definition we talked about previously of the employees, contractors, and trusted business partners. What we do, and we have recently expanded to, we do include the unintentional insider threat into our research as well. These are the individuals with authorized access to those critical assets, and they harm the assets from the confidentiality, availability, or integrity standpoint, but they do it without malicious intent. Again, these could be described as the accidental insiders, individuals in your organization who accidentally impact the organization's critical assets, but that does need to be factored into your enterprise-wide risk assessment as well. And I know that many organizations don't necessarily care initially about the motives of the insiders when you're trying to recover from an event or detect an event or prevent an event. But you as an organization, the protection strategy being the critical asset level, when you get into the motives of the individuals, that may come into play when you're looking to prosecute someone if there's true malicious intent, or at another scenario being someone being terminated for some activity. But again, initially, we believe that organizations should focus on the critical asset protection strategy, and then you need to consider people who intentionally attempt to harm the assets, or from an unintentional or accidental standpoint, still impact, you still need to recover, but from a standpoint of there is no malicious intent. Okay, when we break these incidents down, we want to try to describe these as the impact of the organization. We have a number of incidents where we have IT sabotage. IT sabotage, as the definition describes here, directing specific harm at the individual or the organization's critical assets. The critical assets primarily being the technology. And we have 171 incidents of IT sabotage we've collected over the years. We've analyzed and we've built the patterns of activity. The second type of incident will be theft of intellectual property. Theft of intellectual property, we have 109 cases we've collected over the years. This is where an insider uses IT to steal or take intellectual property from the organization, and it usually has the motive of some business advantage for the individual. Insider fraud, as the name implied, we have a number of cases, 298 cases to date. As the name implied from fraud, it could be the theft of money. Certainly personal gain or financial gain is the primary motive, but also consider incidents where someone in a position with authorized access to an application or a system is able to add or modify or delete data. Again, those are also categorized as insider fraud. And we also do research into national security espionage. Again, as the name implies, impacting the U.S., and many times that does deal with the stealing, delivering, or attempting to deliver critical information, again, at the detriment of the United States. We have 147 of those cases. So what I want to present to you in the next minute or two is the insider threat crime profiles. I do want to offer the option of following up later on. This is a 1 to 2 minute presentation for each of the profiles. Much more data available on our website, the Insider Threat website. Feel free to go to that anytime. A number of reports and publications are available from that standpoint. So when we talk about IT sabotage, as we said from the definition standpoint, the use of IT to disrupt or to make unavailable, impacting the availability of an asset, and that typically will get to the critical asset being the technology, and in some cases the information itself. A couple of cases that we just want to present here show the impacts. We believe that most organizations are relying upon an IT system, and that IT system could be compromised, and we do believe that most organizations should consider IT sabotage as something they should be concerned with. One particular case, we had a contractor in our database that we've collected, a contractor who worked for an organization that was actually developing and deploying and monitoring SCADA systems for oil exploration companies. This contractor who applied for permanent status with the organization, when he applied for permanent status, it was rejected. Obviously, that was from a standpoint of disgruntlement event. This individual was disgruntled. He basically did, when he left the organization, deployed some malicious code which disrupted the communication from the onshore facilities to the offshore facilities. Obviously, that's impacting a critical asset being the technology. If we look at a couple other events, this also would impact banks, financial institutions. We had cases in banks where a disgruntled system administrator sabotages the systems. All the customers for this particular financial institution lost access to their asset, being their money, for a period of 3 days, from a Friday evening all the way till Monday morning. Another case, a subcontractor at an energy management facility. This was a contractor. He had a dispute with his contracting organization. They suspended him on a Friday, but they failed to notify the energy management facility. This individual still had a badge and authorized access to the energy management facility, came in on a Monday or a Sunday evening and disrupted the exchange of electricity communication between the power grids. Certainly an impact, critical assets. Automobile dealer, an employed automobile dealer, manufacturer, was laid off just because of financial issues related to the organization. They laid him off, but he still had authorized access to disable some of the vehicle control systems. He actually sent out unwarranted signals to the vehicle control systems, disabled some engines of cars that were in operation, and set off the alarms. Again, significant impacts. And finally, consider the facilities and the access of people. Security guard at U.S. hospitals submitted resignation, obtained physical access to the computer rooms, installed malicious code on the hospital computers, which were running the HVAC systems, as well as some of the patient medication and record systems. So if we look in summary of the insider threat to sabotage, again, who has authorized access to technology, who has authorized access to impact the availability of those assets. Many of the cases that we have are former employees. The particular motive of these individuals are disgruntled employees. They want to get revenge for perceived injustice. and many of the individuals, because of the need to modify those access, had technical privileges above and beyond normal usage, administrators' privileges, programmers, DBAs, primarily male in terms of gender, but that necessarily shouldn't be surprising. If you look at the U.S. Bureau of Labor and Statistics, over 90% of the positions in those technical administrative programmer roles are still occupied by males. Target network systems data, unauthorized access, and typically outside normal working hours and with remote access. So that describes the insider threat in terms of sabotage. Again, depending upon what you're trying to protect, if you're trying to make the availability of the asset being the technology, consider that in terms of the motives, but also the impact to the organization. Now let's compare and contrast that very quickly to fraud. Fraud, as the definition we described before, was adding or modifying or deleting data or the theft of money or some financial benefit to the individual. Again, consider from your individual organization standpoint, what if someone on the outside targeted one of your employees and were to pay them for some action they would take on your networks and to your data? Okay, could they do something like that? So from a standpoint of consider people who have authorized access to your applications, if they were targeted, they could potentially be incentivized by financial gain. In one particular case, there was a ring of employees at a Department of Motor Vehicles in the U.S. They sold identity documents over a period of a number of years, 200 fake licenses and other identity documents totaling more than $1 million. In this particular incident, it was suspected. They brought in law enforcement, and a law enforcement person who was starting to identify the ring of employees actually clearly identified that he was on the no-fly list, and the reason he wanted an identity document was that so he could fly. So think about that from a fraud standpoint. Financial gain on the part of the individual. They had authorized access to generate the documents, and that's where we get into the modification, addition, or deletion of data. Other cases of fraud, just think about, do you do some types of payments? An accounts payable clerk over 3 years issued 127 unauthorized checks, totaling $875,000. Think about also the personally identifiable information that you may collect on your employees and or your customers. That is a target. That could be used to sell the information outside the organization, commit some type of identity theft and or some type of credit card theft. Think about also data that you have on your employees. A database administrator downloaded 60,000 employee records, sold it to someone on the outside. And then finally, another case, an office manager at a trucking firm put her husband on the payroll for weekly payouts, would generate a check to her husband, then would remove her husband from the employee records once the checks were paid out. So again, it could be the theft of financial assets, but it also could be someone being paid to add or modify or delete data. So if we compare and contrast fraud to IT sabotage, these tend to be current employees with authorized access to your applications, systems, or data or processes. Non-technical in many cases, they don't need to have the technology or the administrator privileges because they have authorized access throughout their applications. Customer service, data entry. Also, we've seen a number of cases recently, which we'll talk about in the fraud scenario, the fraud session this afternoon, about the number of managers that have been involved recently in a commission of fraud. Gender fairly evenly split, target PII customer information, and authorized access. Authorized access during the normal working hours. So again, the goal is to compare and contrast. What are you trying to protect? IT sabotage, which is the technology, fraud, primarily, which is the data. And then finally, comparing and contrast that to theft of IP, as the name implied, stealing the intellectual property, the confidential, sensitive, or proprietary information. Okay, if we look just very quickly at a couple of cases here, in one case, a research scientist downloaded 38,000 documents before going to work for a competitor. That information was valued at $400 million. Significant impact to the organization. What was interesting about this particular case is that this wasn't detected by the victim organization. They had logging in place. They found out that he downloaded 17,000 PDF documents, 22,000 abstracts, but it wasn't detected until he went to the new organization and started uploading it onto their network. They notified the victim organization, which started the investigation. When they did the investigation, they logged all of that activity, but they weren't able to be proactive when the information was being transferred. When they did the investigation, they found out that he was downloading information at the rate of 15 times higher than the next highest user during that period of time. So they were logging the activity, but they didn't have the capability, nor did they alert when the suspicious activity was happening. Other cases, Technical Operations Associate Pharmaceutical Company downloads 65 gigabytes of information. Now that might violate your threshold within your organization, but it may not. It's up to you as an organization to determine what is an amount of data that could be considered suspicious, but also combine that with the individuals who may be leaving the organization. 65 gigabytes, if you're leaving tomorrow, in many organizations that should be considered suspicious. And then finally, the impact to another organization, a nuclear power plant, simulation software, a contractor was managing it. That was basically looking at the reactor control status of rooms within a nuclear power plant. This former software engineer went out and took the software with him, went to work for a competitor in a country outside the U.S., and they started seeing attempts to connect back to this nuclear power plant within the U.S. So again, intellectual property could be the software that's running on your systems as well. So finally, wrapping this up in terms of the final comparison of the three types of incidents we've done primarily in terms of analysis: theft of IP, current employees, but also consider that 30 days of announcing they're going to leave. Might be your window of opportunity to reduce the search space down a little bit. Think about the people who have authorized access to your IP: technologists, scientists, programmers, engineers, salespeople, primarily male. Target the IP or customer information, authorized access, and during normal working hours. So the reason we present these three patterns is that we want you to focus on your critical assets, who has authorized access to your critical assets, and what can they do to impact the assets. So again, for more information about these three types of crimes, feel free to go out to our website to find this. So I want to now pass it on to Dave Mundie to talk about ontologies for insider threat research.
Thank you, Randy. So there is an ancient Chinese proverb that says, the beginning of wisdom is to call things by their proper name. And that seems kind of basic, kind of fundamental, but a couple of years ago, back in 2010, when the Department of Defense decided that what we really needed was a science of cybersecurity, which is a phrase you hear a lot these days, they realized that there was no such science, and they went to the MITRE Corporation and asked MITRE to look at the scientific community and figure out what it would take to turn information security into an actual science. And the first conclusion from the Jason report, which came out of that effort, was that the most important thing that the community needs is a common language so that we can call things by their proper name. That is to say, the name that we have agreed to use for these, and a set of basic concepts about which the security community can develop a shared understanding. And that really is where science starts. And so I'd like to tell you about some work that I've been doing with some colleagues of mine to try to use the technology of ontologies to do that for some of the work that some of the domains that we've been working on. One of my inspirations here is the medical community. If you go to a site called the Ontology Lookup Service, you can find these wonderful medical ontologies where the medical community has agreed on what the definition of a mitochondrion is. And if you start calling a gallbladder a mitochondrion, there are curators of this vocabulary that will come and say, hey, we've got a problem here. And the origin of ontologies in computer science goes back to 2001 when DARPA decided that what would be a really good idea is if we could apply some artificial intelligence to the web. And Tim Berners-Lee, who had created the World Wide Web and needed a follow-on project, said, oh, let's create the semantic web. And between the two of them, they came up with the web ontology language, or OWL. And all of these medical ontologies are written in OWL. The 11th version of the International Classification of Diseases is one large OWL project. And Google has picked up on this, and the Google's knowledge graph that they used in their search engines and so forth is all based on ontologies and OWL. And they now have a absolutely huge semantic network with over 18 billion facts, and that is what allows them to do such a good job of formatting and displaying your search results. And so this technology has come a long way, and what we are trying to do is to apply that to information security. Maybe I should say what an ontology really is, and it's very simple. It is that standardized name. It's the controlled vocabulary where we say, as a community, that here's what we mean when we use this term, plus the relationships among the terms in that standardized vocabulary. It's really not that deep, but it is enough that you can start applying artificial intelligence technique, machine processing to it. So we have been doing ontology work. We haven't always called it that, but for the last 5-6 years, we started off doing this for incident management, and we have a body of knowledge for incident management. More recently, we had a project to develop an ontology for malware analysis because we feel that malware analysis is one of the subdomains that desperately needs this approach because they don't have a standardized vocabulary, causes problems with their customers who don't use the same language and so forth. We developed a standardized methodology for developing ontologies, which I still think is a very valuable thing to have. It's certainly what we use in our work. And more recently, we have begun applying this to insider threat. I'll just mention 4 of the ontological projects that we have here. The lexicographic insider threat ontology. There is this issue of where do you go to find an ontology? And one place is existing representations of the knowledge. And I'll give you an example of that. There are a couple slides on this lexicographic approach. Another one is the trust ontology. I personally think that this concept of trust is absolutely essential for understanding insider threat. And there's a couple of Italians that have a wonderful model of trust. And we have created a formal ontology that captures that trust model. I'll also tell you a little bit about an indicator ontology, an ontology of insider threat that is designed for indicators and for developing indicators. And then most recently of all, an unintentional insider threat ontology. And Randy mentioned that we have recently started looking at non-malicious insider threats, and we're capturing that in an ontology. So let me say a few words about this lexicographic approach that we took. Just as a point of curiosity, this is the Google Ngram viewer for insider threats, and you can see that the volume of discussion and literature about insider threat has risen dramatically since 1996. That's when it's essentially quadrupled since then. And one of my colleagues was doing a literature search of that enormous body of work. And what she noticed was that there were 42 different definitions of insider threat in all of that literature. And Randy gave the definition that we have been using at the Insider Threat Center for the last 10 years. And it's a fine definition, we think. But if you really want to get the entire community to agree to one ontology, I believe that you sort of have to start with what's already out there. And so we looked at those 42 definitions, and just give you a couple examples. One definition says that, an insider threat is someone who is authorized to use computers and networks. Another one is, it's anybody who's operating inside the security perimeter. Well, how do you reconcile those? And we were inspired by Travis Bro, who's a researcher on campus here at Carnegie Mellon, and he uses OWL, the description language, to capture breach notification laws, the laws that states have, because it's really messy. They've got 48 different breach notification legislation, and he coded it in a formal language. And so we were inspired to do something similar. So we code that first one as is insider anyone authorized to use computers and networks. And once we'd done that, we began to see that there was a model here. There was these standardized terms and the relationships among them. And so there's the organization, there are the assets and the individual, and the organization trusts the individual, and the individual then can betray that trust, and there are a bunch of attributes that are applied. And so we began to build up this conceptual model, which really is an ontology. And we eventually put this in Protégé, which is the standard tool for developing ontologies, into a class hierarchy that also has the relationships and so forth. And so this is in my mind, a very powerful way of capturing this body of knowledge, this domain, and it's very compatible with the system dynamics models that we've developed and so forth. It really blends well with the other research that we have. Briefly, the other project that we're working on, the ontology for indicators, this is something that we've developed in collaboration with one of our sponsors. We had 4 goals. One is to focus on detection, because that is what most people are concerned about. How do I detect insider threat? And as Randy mentioned, we don't have a really satisfactory set of indicators now. We wanted to make indicator definition simple, to be compatible with existing models, and so on and so forth, and be easy to extend, and so on. So we took the model that we were given, and once again, we put it into Protégé, into a formal OWL ontology. And the key thing here is that there are the 5 main factors in this model: the analysis, the object, the action, the entity, and the time frame. And from that, you can begin to put together indicators. And we're using a subject-verb-object syntax, so if the entity is security role entity. But because this is in a Protégé ontology, we can get rid of most of that and come up with an indicator that just says if the system administrator performs printing on any data object within non-work hours, you better do an investigation. And I think that you can see that this is a pretty clean framework for developing indicators. So I see ontologies as a pretty useful, not very hard to implement tool for doing a lot of the insider threat research that we're currently interested in. So,
thank you, Dave. So as we wrap up this first session of the day, we certainly encourage you to come back throughout the day, a number of topics which will be given more detail throughout the day. But what I want to leave you with is the offer to work with us in the future. Given that we're a federally funded research and development center, we want to offer to you to provide feedback in terms of our future research directions. We do want to work with the operational community, and our mission as an FFRDC is to research some of the tough, complex problems or the challenges you're facing within the operational community. The final session of today, the panel session, will talk about some of those challenge problems, but I do want to make that offer. Feel free to reach out to me or anyone on our team to help us direct the future research going forward. But some of the services that we might be able to provide and may be valuable to you is, over the years of research, we were able to compile all those cases, the 800 plus cases. We were asked by organizations to build some type of way to assess their organization against insider threats. We built an insider threat assessment methodology where we can actually assess organizations against what we believe are the issues or areas of concern within your organization. What we can do is we can come in and help you measure your preparedness level to address, prevent, detect, or mitigate the insider threat. What we would do is we come into your organization, we work with you to review the documentation you have in place, we watch and look at the process you have in operation, and we do interviews with your subject matter experts. And the outcome of that is a confidential report of findings with some recommendations. Really what we want to focus on is all aspects of your organization, to include the information technology, security, software engineering, the data owners, human resources, physical security, legal and contracting, and trusted business partners. So if you're interested in the insider threat assessment and the process itself, please go to our website. We have white papers that can describe the process. We can help you assess insiders and the threats they pose to your organizations. If you're interested in training opportunities, we do a number of publicly available training opportunities, but we also do specific organization insider threat training. That could come in the form of a half day, 1 day, or 2 days, and really can work with you to work with different parts of your organization to train and raise awareness of the insider threats, as well as get into some of the best practices for the mitigation of insider threats. And then finally, if you're interested in building an insider threat program, we do have the ability to work with you to come into your organization and help you stand up an insider threat program. Again, that could be a series of 3 days to 5 days on site, and we can really work with your senior executives on building a strategic action plan for the prevention, detection, and response to insider threats. So for more information about those 3 specific services we have available, please go to our website, www.cert.org/insider_threats. And throughout the day, we'll be referring back to some of the assets which are listed up here on your screen. The Common Sense Guide to Mitigating Insider Threats, we have the URL to that. For information about the workshops, the assessments, some of the new control work that's coming out of our technical solutions team, specifically the Insider Threat Lab that we have here in the Insider Threat Center. Go out and you can find those controls on our website, some exercises. And then finally, within the past year or plus, we've actually released a book really trying to compile all of our years of research into one particular source. So in terms of next steps, I do believe we want to open up for questions. If there were any questions that were submitted, we'd be glad, David and I, to answer those questions.
Okay, so let's get to some questions from Israel asking, we are finding private sector companies that provide key functions to critical infrastructure, federal and gas, that believe because they're an LLC, there is no overseeing government agency or compelling reasoning to address advanced persistent threats from foreigners. Can you comment on this or other companies that are knowingly ignoring this remediation of such threats?
Well, certainly from the advanced persistent threat scenario, the area that we've done the most research on, specifically the Insider Threat Center, is how individuals outside the organization could work with individuals inside the organization to gain access to those critical assets, being the information and or the technology. Again, once the outsiders are inside the organization perimeters and on the networks itself, then they basically have the ability to impact the critical assets. From an organization standpoint, it certainly should be a threat that should be considered. From an organization standpoint, focusing on a critical asset protection is something that should be of concern. And at least initially, when you're trying to prevent an incident from happening or detect when it's happening, at least initially you may not be concerned of who is impacting the critical asset, whether it's internal or external, but it still should be part of your protection strategy. When you start commenting on the legal aspects of what you should protect, and how you should report it, that would be specific to your organization, the sector that you're in, as well as the country or the geographic location that you're actually responsible from a federal, state, and local enforcement policy. So if you're interested in the insider threat component of the advanced persistent threat, we can comment on that. For other information on advanced persistent threat, I would suggest going to the CERT website and finding someone else in CERT who can maybe provide a little more context to the advanced persistent threat that doesn't involve insiders being involved in that threat.
Okay, I think this question is related, but I have to ask it. Sure. And I'm going to generalize it because I know certain things we cannot comment on. But in regards to the target, impact, and actor approach, do you see more federal agencies or even organizations adopting that approach? If so, do the case studies we have show where they're failing in those areas?
Well, certainly from again, our opinion, if you focus on protection of the critical asset, that should be the start of a piece of your enterprise-wide risk assessment, identifying what the assets are, who has authorized access to them, and who should have authorized access. And then if we can put the controls at the asset level, we might be able to identify the suspicious activity. Now, from a standpoint of the organization trying to protect that from an external or internal, again, at least initially, the operational community is really focusing on the prevention of data loss, the prevention of information assets being unavailable, the availability perspective. So from that standpoint, the prevention strategy should be at the asset level. And then if we can then do the risk mitigation strategy of who has authorized access, then we might be able to focus our research perspective or the security perspective then on who has authorized access, and then start looking for the variance from the normal activity on those critical assets. Again, many of the tools that are out there, you'll hear this again in the next session, there are tools out there that could alert on certain activity. But when you try to combine that with what is normal activity on your networks and systems, That's where organizations are being challenged. What is considered a variance from normal activity, given that these insiders have authorized access to your critical assets, and they access those assets many times on a daily, hourly, or on a minute-by-minute basis.
Okay, question for David, and I'd like to fit two more questions in if we can here. Saying from the Ontology section asking, and this is from Tim asking, it isn't directly relevant to insider threat, but could you say a few words about malware analyst ontology? Do we have any research in that area?
Yes. As I mentioned, we did have an internal R&D project to develop a standardized vocabulary for malware analysis. And that was published as a tech note on our website. Recently, we have been in negotiations with some of the people at the malware analysis team inside MITRE to extend that into a true competency model. Ontology-based competency models is a hot topic in the last 5 years, and that's the competency model. That is to say, the list of things that a malware analyst needs to know and the things that they need to be able to do is a huge problem, because you hear horror stories of people getting hired and being put in a malware analyst position because they know how to configure a firewall, and it's all security, right? And it's because we don't really understand what a malware analyst needs to know. And so we are working to extend that initial project into a full-blown ontology-based competency model.
Okay, great. One more. I think we're going to focus this one to Randy from Ron asking, how do you recommend using tools to identify the non-technical observables within an organization?
That's a great question. So certainly there are a number of tools that are data aggregation tools. We can pull data from different parts of the organization and pull it together into one data source. The challenge from a tool perspective is then how do we analyze the data, and many of the tools can't analyze the data. But when you start reaching out to the non-technical aspects of your organization, the human resources, in many cases the physical security aspects of your organization, certainly there are issues that need to be considered of what you're trying to get from those organizations. Many organizations struggle with the policy aspects of, can a tool, an IT tool, go and get data from the HR systems? Can they go and get data from the physical security systems? Once you overcome that boundaries or those silos that many organizations struggle with, then you have the ability to go and pull some of that data. What we would suggest is that when you start looking at some of the people who may be more at risk at harming your assets, some of the things that you could identify from the HR systems could be the people who are leaving your organization, they resign from your organization, are being terminated from your organization. A tool could go to a personnel system and identify people who are leaving. When we start looking at the physical aspects of that, there are tools that could go out to your physical security systems and pull data and badge access into areas or attempts into areas. So there are a number of tools that are out there that can connect to data sources. The challenge that you as an organization have is that how can you get to those data sources, but also are you able to get to those data sources? Many times that comes down to a policy decision, and how can we get to that?
Okay, I lied. We got one more great question come in, so if we can address it quickly if possible, that would be great. Ben asking, does length of employment influence the likelihood of insider threat?
So that's a great question. From a standpoint of empirical data, one of the things that we will address in the insider threat fraud session is when we looked at insider fraud specifically, we found that there was on average of the fraud incidents about 60 months from the time that an individual was hired in an organization until they started committing the fraudulent activity. These were people who had time to identify what the controls were in place, and they knew what the controls were in place, what the fraud detection strategies were. So in that particular incident, from a fraud incident based upon the data itself, we found there was significant length of employment from the people who came into an organization until the time they started committing the fraud.
And if I could add something
Sure.
to that, I've been working on the unintentional insider threat project, and we've been looking at social engineering, and length of employment plays a key role in a lot of social engineering attacks. This is somebody who's been working for us for 8 years, and you let your guard down, and that's one of the dynamics that we're building into the model for unintentional insider threat for social engineering.
Yeah, and one of the things, just finally to wrap it up in 30 seconds, one of the things that we stress to organizations is what we describe as the trust trap. Many organizations fall into this trap when they tend to have employees in a significant length of employment. They tend to trust their employees, but they tend to let down their controls in terms of detection of suspicious activity. The longer that someone's there, the more you tend to trust them, and the less you tend to look for suspicious activity. It gets into this cycle of you trust, but you don't look. If you don't look, you're not finding. And it's this cycle of people aren't being watched, and the defense in depth strategies and the trust but verify model isn't consistently followed.
Dave, Randy, great presentation. Thank you very much.